This video is a continuation of yesterday's lecture. So yesterday we have discussed moment generating function, and based on the moment generating function we have done a problem. In that one we got the answer for rth moment and fourth moment answer. Now one or two problems are left over. So today we will complete that. Look at the question. If a random variable x has the mx of t equal to 3 by 3 minus t, find the standard deviation of x. So standard deviation is nothing but the root of the variance value, as I told you already in the class itself. So look at this question. So in this problem, the question is find the standard deviation. Directly we are not able to find the standard deviation. Before that we need to find mean and variance so that we can easily find the standard deviation. So the mx of t is given. So using moment generating function means we have to go for the first derivative and second derivative and make the t equal to 0 so that we can get the mean and variance easily. Okay. Now given mx of t equal to 3 by 3 minus t. Okay. For the differentiation convenient, we can write this as 3 minus t power minus 1. Okay. Now we are going to differentiate with respect to t. So that first derivative, that is mx dash of t, 3 is a constant. When you are differentiating this minus 3 minus t power minus 1, bring the minus 1, then 3 minus t power minus 1, so minus 2. Differentiation of minus t is minus 1, and minus into minus, this will become as plus, so that we can get 3 into 3 minus t power minus 2. This is our mx dash of t, that is first derivative. Okay. First derivative is nothing but our mean, that is the e of x. Therefore we know that e of x is equal to mx dash of t equal to 0. So in this one we are going to put t equal to 0. Then what will happen? 3 into 3 minus 0 power minus 2, that is 3 by 3 square, that is nothing but 3 by 9, that is equal to 1 by 3. Okay. Therefore our first, that is first moment or mean or e of x, which is nothing but e of x is equal to 1 by 3. Okay. This is our mean. Now we are going to find the e of x square, that is second derivative we are going to find. E of x square is nothing but mx double dash of t, that is our e of x square. In this one we have to put mx double dash of t equal to 0. The answer for the mx double dash of t is 6 by 27. Okay. So now variance result, we know that what is the variance result? This can be written as 2 by 9, cancelling by 3. Okay. So we know that variance of x is equal to, what is the result we have know? We have know that e of x square minus e of x the whole square, variance result. Variance of x is equal to, what is the result? Variance of x is equal to e of x square minus e of x the whole square. E of x square is nothing but 2 by 9. Okay. 2 by 9 minus e of x the whole square. What is our e of x? E of x is nothing but 1 by 3. Okay. So 1 by 3 the whole square, that is 2 by 9 minus 1 by 9. So what is the answer? 1 by 9. Variance of x answer is 1 by 9. Okay. This is our e of x. E of x is 1 by 3 and variance of x is 1 by 9. The question is find the standard deviation. So we know that standard deviation equal to root of variance. Okay. So standard deviation is nothing but root of variance of x. So which is equal to root of variance of x is what? 1 by 9. Okay. Therefore our standard deviation, root 9 is nothing but 3. So standard deviation answer is 1 by 3. Okay. So using moment generating function, find the standard deviation means first we are supposed to find the first derivative, put t equal to 0, that is our e of x, and find the second derivative, make t equal to 0, that is our e of x square. So variance result is nothing but e of x square minus e of x the whole square. Substituting the values here, we can get variance of x is equal to 1 by 9. We know that standard deviation is nothing but root of variance value, that is equal to root of 1 by 9. So our standard deviation equal to 1 by 3. This type of question also come. Look at the next question. If x represents the outcome when a fair die is tossed, find the MGF of x and hence find e of x and variance of x. Okay, x represents the outcome of fair die. Okay, so what is the P of x? Here directly P of x is not given. Instead of that, it's given that x represents the outcome when a fair die is tossed. So tossing a die, what are the possible outcomes? Okay, so we have 1 by 6, whether it may be 1 to x takes value 1, 2 up to 6. Okay, so the possible outcome is 1 by 6. So now we know that moment generating function definition, mx of t equal to what? Sigma e power tx into px. See, here I am writing px. It's understood that x is a discrete random variable because we have the outcome as 1 by 6 when tossing a fair die. Okay, so obviously the random variable is a discrete random variable. For the discrete random variable, the moment generating function is mx of t equal to summation e power tx into p of x. If suppose it is continuous, means we are going to use integral value. So here it is a discrete random variable, so that only we are writing sigma e power tx into p of x. Obviously the x takes the value from where to where? X takes the value 1 to 6. Okay, so mx of t equal to sigma x equal to 1 to 6 e power tx into 1 by 6 p of x. Okay, so sigma 1 to 6 e power tx into p of x. P of x is nothing but 1 by 6. Okay, so here x equal to 1 to 6. Limit for, that is the summation value takes only for x. So we can take the 1 by 6 outside. Okay, 1 by 6 into first value of x equal to 1, so we can get e power t. Okay, then the next value is e power 2t, e power 3t plus e power 4t plus e power 5t plus e power 6t. Up to 6 only x takes the value. Therefore our mx of t, that is the moment generating function, is nothing but 1 by 6 into this one. Okay, so now I am going to find the first derivative, because the question is find mean and variance, that is e of x and variance of x. E of x is nothing but what? E of x is nothing but mean. So another notation is mean, and we can denote it as mu1 dash. Okay, so mx of t is a moment generating function taking the first derivative, that is nothing but mean. So here we are going to differentiate this with the respect to t. So what will happen? 1 by 6 is a constant, differentiation of e power t is e power t, plus differentiation of e power 2t is e power 2t into 2. So that can be written as 2 into e power 2t, plus e power 3t, differentiation is 3 into e power 3t, plus e power 4t into 4. So we can write this as e4 into e power 4t. Same manner 5 e power 5t plus 6 e power 6t. So this is our first derivative. You can call this as equation 1. Okay, then second derivative, mx double dash of t. Why we are finding this? Because the question is find variance also. Okay, so variance, to find the variance only we are finding the second derivative of moment generating function. So here again e power t differentiation is e power t, 2 is a constant, differentiation of e power 2t is e power 2t into 2, already one 2 is there, so this will become as 4 e power 2t, plus same manner here 3 is there, e power 3t into 3, 3 into 3 9, so 9 e power 3t, plus the next term is 16 e power 4t plus 25 e power 5t plus 36 e power 6t. Okay, this is our second derivative of moment generating function. We can call this as equation 2. So why we are doing this? Because to find the value of mx dash of 0. So mean e of x is equal to, we know that mean e of x is equal to mx dash of 0. In the first derivative, wherever t comes, put t equal to 0. So what will happen here? E power 0 value is 1, and here also e power 0, this is also e power 0, e power 0, e power 0, e power 0. So only we can get 1 by 6 into 1 plus 2 plus 3 plus 4 plus 5 plus 6. Is it clear? Because e power 0 value is what? E power 0 value is 1. So that we can get answer is, look at this, 21 by 6. We can cancel by 3, so that we can get 7 by 2. This is our mean, that is E of x. Therefore, our E of x is equal to 7 by 2. Now we are going to find the variance. For that we know the result. What is the result? E of x square minus E of x the whole square. We got only E of x. So we are supposed to find E of x square. That is E of x square equal to what? Equal to mx double dash of 0. Already we got mx double dash. Okay. So in this one, put t equal to 0. What will happen? This will become 1. 4 into 1, 9 into 1, 16 into 1, 25 into 1 plus 36 into 1 whole divided by 6. Okay, so that we are getting 91 by 6. Okay, this is our E of x square. We know that variance of x is equal to what is the result? Variance of x is equal to E of x square minus E of x the whole square. Okay, so substituting the value here, 91 by 6 minus E of x. What is our E of x? E of x is 7 by 2. Okay, 7 by 2 the whole square. So variance of x is equal to 91 by 6 minus 7 square is 49 divided by 4. Okay, so when you are cancelling and taking LCM, we can get the answer as 35 by 12. So the variance of x is nothing but equal to 35 by 12. So for the question E of x and variance of x, first we are supposed to write the probability of x. That is nothing but 1 by 6. How we are writing this? Because it's given in the question. X represents the outcome when a fair die is tossed. So the possible outcome when the die is tossed, 1 by 6. Points are from 1 to 6. Okay, so mx of t is nothing but e power tx into p of x. X takes the value 1 to 6. Substituting the value, we are getting mx of t. First derivative, put t equals 0, that is our e of x. Second derivative, put t equals 0, that is our e of x square. Variance of x equal to e of x square minus e of x the whole square. Substituting the value, we can get the variance answer is 35 by 12. Look at the next question. Find the MGF of a random variable capital X having the density function f of x is equal to x by 2, 0 less than or equal to x less than or equal to 2, 0 otherwise. In the question it's given that density function. So obviously the given random variable is a continuous random variable. Okay, and given f of x, what is given in f of x? F of x is equal to x by 2, okay, x by 2 such that 0 less than or equal to x less than or equal to 2. So only mx of t is nothing but mx of t equal to, actually limit is minus infinity to plus infinity. Okay, so original limit of the definition of MGF minus infinity to plus infinity. Here it's given that only in the interval 0 to 2 the function takes the value x by 2. That means in the remaining interval the value is 0. That is what is given, 0 otherwise. Okay, so when you are finding mx of t, directly we can write it as integral 0 to 2. Okay, 0 to 2 e power tx into f of x dx. What is our f of x? F of x is x by 2. Okay, so x by 2 into dx. Here 1 by 2 is a constant, we can take outside. 1 by 2 into integral 0 to 2 x into e power tx into dx. Now we are going to integrate this using Bernoulli's result. Okay, so using Bernoulli's result we can apply that u is x and v is e power tx. U means continuously we can differentiate, v means we can integrate that. So when you are applying that result, we can write this as 1 by 2 into, first keep x as it is, x into integration of e power tx. So e power tx by t. Okay, then minus differentiation of x is 1, again integration of e power tx is e power tx by t, already one t is there, so this will become as e power t square. Okay, what is the limit? Limit 0 to 2. Here I have stopped up to this y because when you are differentiating the 1, it will become as 0. When you are differentiating a constant, that will become 0. That is the reason why we have stopped up to second term. Okay, so now we are going to apply the limit. Okay, limit for x. Okay, 1 by 2 into upper limit is 2, lower limit is 0. So 2 into x is there, no, wherever x comes we can put 2. So 2 e power 2t, okay, e power 2t divided by t minus here also e power 2t by t square, okay, this is our upper limit, minus lower limit is 0, 0 into anything 0, first term is 0, minus here e power 0 value is 1, so 1 by t square, this is our lower limit. So this can be written as 1 by 2 into 2 e power 2t by t minus e power 2t by t square, minus into minus plus 1 by t square, okay. Now commonly we can take the t square, so this can be written as, here only t is there, so 2t e power 2t, and here it is minus e power 2t plus 1, okay. So this is equal to, we can write it in a order, 2t e power 2t minus e power 2t plus 1, okay, whole divided by 2t square. This is nothing but our MGF. MGF is denoted as mx of t. So the required MGF is nothing but 2t into e power 2t minus e power 2t plus 1 whole divided by 2t square. So for this question is a different question. So the p of x is not given directly, instead of that it's given in the previous problem. Here it is f of x, so the continuous case we have the integration e power tx into f of x, so that we can done. So in the previous question it is given that a fair die is tossed, so that our p of x is 1 by 6. So when p of x comes itself, we can identify that the random variable is a discrete random variable, so that only here we have applied a sigma e power tx p of x, and in this question it's given that f of x, okay. So the density function is given, obviously the random variable is a continuous random variable, that is the reason why here mx of t equal to, actual definition, mx of t equal to integral minus into plus infinity e power tx into f of x dx, okay. So this is our actual definition for MGF, and in this question the limit is 0 to 2, that is the reason why we have taken directly 0 to 2. Actual limit is minus into plus infinity. It's given that remaining places the value is f of x value is 0, so that directly we have written 0 to 2. So applying that, integration applied and Bernoulli's result, using that, applying the limit, we can get the MGF as mx of t equal to 2t e power 2t minus e power 2t plus 1 whole divided by 2t square, okay. So up to this the problems, all the problems completed under the moment generating function, so that we have completed the first unit, okay. Thank you for watching.